I'm going to teach you a software called Capture CIS, which is basically software belonging to orcad software package. And now I'll introduce you to the software. It's a software that's used to do simulation of electronic circuits. And first of all, we go to File, the New, File, New, and Project. I select Analog and Mixed A/D, choose the folder, and then I name it test1. Oh sorry, it's already this, so I name it test2. I choose create blank project. I click on OK. Then I click on this workspace and choose place path. These are libraries which are already added, not by default. I've added them. Now I will teach you how to add these libraries the first time you're starting orcad. Add library, and then you can choose different libraries by selecting first of all analog, then type A, and the analog library comes, and type S, source library, D for getting the diode library, which is here, and so on. So you can get the libraries. These are diode, bipolar, analog, E bipolar, E diode, and source. Design catch is by default, and you can select various components in these libraries. Now I'll exit from here. This is for wire placing. This is for ground. By default we'll get this used as source, and we have to use this only. Now I'll start making a circuit using this software. I'll go to place part. I'll go for diode, and I'll choose something which is like an NPN diode. I'll just choose it, and to make it bigger I'll choose zoom to region. I'll make a region and zoom now. Now I will choose a wire. Not for wire, I'll choose a component which is a resistor. I'll go to analog and type R and choose a resistor. By default value is 1k. I place it like this. Then I need one ground. Of course without ground your simulation won't work, so if I want to simulate I have to have a ground. Now a source, that is a AC source, because I want to see the rectification. So I like to have an AC source with me. So I go to source, then go for V, and go down, and I'll have something called VSIN. That's an AC source. Now I connect them using wires. So I'll choose the wire component and connect it like this. It's very easy. And go connect it. It's done. Now I'll choose to connect this. Now as everything is done, I'll now start off to give the values. 1k is okay. Now give the V off. I'll give it 0, mostly 0. Then amplitude of the voltage of sinusoidal wave, I'll give it 10, and the frequency I'll give it 1000 Hz. Now frequency is 1000 Hz, so time period is equal to 1 pound frequency. That will give me 1 millisecond time period. To analyze this, I will first go to the PSPice new simulation profile. I will name it test and press enter. This is time domain. I will choose 3 milliseconds to get 3 cycles, because 1 millisecond was also 1 cycle, so 3 cycles I will get 3 milliseconds. I'll click on OK, and now I run this. I'm getting an empty graph because I have not selected a parameter yet. Now I will go to add trace from trace, and I'll choose various parameters. First of all, I'll go for the source voltage. That's a sinusoidal wave. That will be available on the resistor. So I'll get for VR1, like this one. Let's check it out. This sinusoidal wave is going till 10 volts. Now I'll add more trace. That is VD1, that is voltage from 2 diode. Now look, this has been rectified. Half the rectification will be done here. So now what is happening over here? The diode gets on at a voltage which is about 0.7, and it remains on. So when it's forward bias, it will remain at 0.7 volt, and reverse bias, it is not in it's an on-off condition, so it will get the voltage similarly. So we'll get the negative voltage is -10, but the positive voltage will remain till the value specified is 0.7. So this is not actually a half-wave rectifier. You can call it as a clipper circuit. clipper means I'm clipping off the output, the input. So now you can see the red one is the output and the green one is the input. So that was what I wanted to show you. For a better view, you can have it click this also. So this is what I show you. Okay, so let's sleep. Stop it.